In this session, we're going to talk about C operations and the operators that allow us to do those things. There are 5 main types of operations: arithmetic, assignment, comparison, logical, and compound. Arithmetic is pretty straightforward. We know we can do things like addition, subtraction, multiplication, division, and a special kind of division called modulus, which gives us the remainder. So this is the modulus operator here. The others are pretty straightforward: plus for addition, minus for subtraction, the star for multiplication, and the slash for division. Then we have 2 in C, two plus signs together, or 2 minus signs together, which mean increment or decrement a variable. And then we have a plus sign or a minus sign that would provide a sign. So in other words, make something -1 instead of 1. In terms of assignment operators, we have 1, and it's a single equal sign. Now it's important to differentiate a single equal sign from a comparison equal, which is a double equal sign. And that's a very common mistake, is in a comparison statement to use a single equal sign, which is actually going to assign a value instead of the required double equal sign. So that's something to kind of log away in the back of your head, that we have 2 different operators. Our assignment is a single equal and a comparison is a double. The other comparison operators allow us to do things like check for less than or equal, and greater than or equal. So we can see less than or equal, greater than, and greater than or equal, along with the double equal sign, which tests for equality, which we've talked about already. In terms of logical operations, we can say we want something the inverse, and that would be considered a not, and we use an exclamation point for that. We have a logical or, which says, is this true or that true, and we use a pipe symbol for that. And then a logical and, are both of these conditions true, and we use an ampersand for that. And then finally, our compound operators shown here. We have a plus equal sign, which means we're going to add a variable to something that already exists and assign it. So here we're going to subtract and assign, we're going to multiply and assign, we're going to divide and assign. We could also do a modulus and assign. So we could also do a modulus and assign. In any C textbook or online, you're going to be able to find a list of the order of operations. And this tells us that the same way BEDMAS in math tells us that we need to use brackets, then exponents, then division, then multiplication, addition, and subtraction, we have that same order of operations for C things. So we can see here brackets are right at the top. Then we have exponents. Exponents are handled a little bit differently in C. We'll talk about that as we move on. Division is down here, along with multiplication and modulus. Addition and subtraction are here. So that looks after the math ones, but you can see we have a lot of other operators in C. So we have things to do with data types, we have our increment-decrement operators, we have our logical operators in here, we have special ones that are type conversions and calculation type things. We have our comparison operators, more logical operators down here used in different places. Then we have our assignment operators and those compound assignment operators there, and then a comma which separates expressions. So you can see we have a lot of different operators here. The important thing to remember is this particular chart, which is available in a book or online, will always identify the order that they're going to get carried out in. So be aware of that. When we're working in C, we have 2 types of things that we're going to see. We have expressions and we have statements. And expressions are really the parts of statements. So if we look at what the definition of an expression would be, it's that it represents one thing. So that might be a constant or a variable, or a combination of those things, so constants and variables put together with operators, or it might be the conditions that we're testing. So it's really something that we need in order to make a C instruction work, but it's one element of. Now once we start talking about statements, we're now into things that are actually going to carry out operations for us. So this is going to make the program actually do something. So we have expressions terminated with a semicolon, which turns them into instructions. And instructions are things that can execute. We have blocks of expressions put together, put inside curly brackets, which together form a compound type of statement, and they're going to execute instructions as well. And then we have control types of statements that are going to control the direction or the order of instructions that are carried out. So those are things like decisions, repetitions, and those generally don't get semicolons, just like our compound blocks don't. Expressions, as they're converted to statements, are always going to terminate with a semicolon. So let's take a look at some sample expressions. Let's look at an arithmetic expression first. So here we have a variable called number 1 added with a plus operator to a variable called number 2. Now, how do I know those are variables? Well, I'm assuming because they're in lowercase that they are. They may, if someone doesn't follow the style conventions of C, they could be constant values, but it's pretty safe to assume that things in lowercase are variables. So here we have two numbers added together, but nothing is done with them. It's not terminated, it's not assigned to anything, so that's considered an expression, a part of an instruction. If we look at a comparison expression, we can see a variable called value being compared to, so there's our comparison operator with 2 equal sign, compared to a constant set value. So again, there's no result here, nothing happens, but this can become part of an instruction. And then finally, a logical expression. So here we have our not operator. So here we have a variable called finish that I'm assuming is a flag. So if we're saying if we're not finished some task, then we can do something. But this particular expression is only part of a bigger instruction. So expressions are going to make up our instructions or our statements. So let's take a look at some sample statements. Let's start with the arithmetic one. We can see here we have a variable called length multiplied by a variable called width. The result of the right-hand side is assigned with our single equal sign to a variable called area. And it's made a statement by putting a semicolon at the end, which terminates it. So we have an expression on the right-hand side, assigned to an expression on the left, and terminated with a semicolon. Then if we look at a comparison statement, we have an if control block here. We have round brackets that enclose a test, and our test compares our position to an upper limit. So we have a variable, is it less than, a constant upper limit. This would actually enclose a form of compound statement by doing something like this. So after that, if we have some instructions we want to do and we enclose those in curly brackets, here these curly brackets are actually a form of a compound statement. Now if we look at a logical statement, we have a variable called result ANDed with a constant mask. The result of this is stored in a variable called isolated bit, and we make it a statement by terminating it with a semicolon. And finally, we have a compound operator here, which says we're going to take result, divide it by value, and assign it to result. So it's the same as result is assigned result divided by value with a semicolon at the end. So these two statements, this one we have here and this one here that says result is assigned result divided by value, both operate the same way. So in this case it's actually a compound operator. Up here we have a compound statement. So let's take a look inside this sample program at where we're going to see our operators. So our first occurrence right here shows up in the definition of one of our constants. So we have a conversion constant here, and it's 5.0 divided by 9.0. So we can see our division operator. This constant is going to get substituted in down here when we use that constant value. So by using that constant, we're making sure that our code is a little bit more readable. Now, let's look for another operator. We have here a subtraction operator. We have two brackets, and we have an equal sign. And that's our assignment operator. So if we take a look at this and think back to that order of operations, we know that the brackets are going to get done first. So we're going to subtract 32 from the Fahrenheit temperature. Then we're going to multiply by the conversion factor. Then we're going to assign it to temperature C. So those are the only operators that we have in here. So we had our division, and we have an assignment operator, brackets, and a multiplication. Now let's look at our statements. So remember, statements are terminated by semicolons, or they're blocks. So let's look first. Here we have two variable declarations terminated by a semicolon. So we're taking a keyword, which defines our data type, and we're reserving some memory for it. Here we have a semicolon, so we have a built-in C function that's going to print something to the screen for us. So that particular instruction is a statement. Next line is also a statement. This is going to read from the user, and it's going to read that temperature in Fahrenheit. The semicolon terminates our instruction, so we have a statement here. We have an arithmetic statement here, and then we have an output statement here that's going to print our degrees Fahrenheit and the equivalent degrees in Celsius. Terminated with a semicolon, so we have a statement. Then if we look top and bottom, we have curly brackets. So inside here, we have what would be called a compound statement. So everything in there is considered a statement that's part of a block. So here we've looked at the operators that we have. We have a number of them used for arithmetic, logic, comparison, assignment, and then we have our compound set, plus we have statements and expressions that are going to make up our programs.